Hello, everyone. We're working through statistical methods for rates and proportions. And we're on Chapter 7, Comparative Studies, Prospective and Retrospective Sampling, Section 7.1, Prospective Studies. All right, a prospective study moves forward in time. So we define our study population by the exposure, and we look forward in time to see what happens with the results. So we're looking at maternal age of mothers being less than or equal to 20 years old versus those who are greater than 20 years old. And then the birth weight of their babies being low birth weight, under approximately 5.51 pounds, or being greater than 5.51 pounds. We are going to look at table 7.1 of our text, which is the same context and design, but a slightly different sample size, because in this case, we are not just taking a random sample of women and looking at the cross section of them. We're now saying, suppose we first take 100 women who are younger than 20, and then 100 women who are over 20, and then let's compare the birth weight of their babies. So this is how it's a prospective design rather than a cross-sectional design. All right, we set up our data set. And we look at our tables. We set up our joint frequencies and our joint proportions. So in this case, we have all of the joint proportions of those individual cells. We can get the marginal proportions, we can get the overall sample size, the joint frequencies, and the marginal frequencies. We can also define this in words of the probability of B given A, B given not A, not B given A, not B given not A. We can calculate the odds of A and the odds of not being an A. And we can also get our odds ratio. So our odds ratio is 2.25. You can also follow along in the text to make sure that you're getting all the values the same as 7.1 through 7.3. We are currently on 7.5, the odds ratio. We can calculate the standard error of that odds ratio estimated from our prospective study, as they do in equation 7.6. We get a value of 0.94. And if we wanted, we could use equation 7.8 to get an equivalent answer as 7.6 for the standard error. And we'll just look that those are equivalent, both equal to 0.9375. All right, we can calculate the phi coefficient and the uncorrected chi-square statistic, just like we did in chapter 6. So we're going to use the same function as we had in chapter 6 to get those values. The uncorrected chi-square statistic equals 3.92, and the phi coefficient is 0.14. Those are given in 7.10 of our text as well. And then we can use the same methods as we did in section 6.6 to get the value of our confidence interval. So we're going to set everything up just like we did in 6.6. We're going to use the same equations. We're going to start at a value of F equals 1. And we're going to start at a value of omega. We're going to get every single iteration of the values of omega, and we finally settle on a value of 0.9322. We can get those final values of A, B, W, F, T, U, V the expected cell counts N11 through N22, and the value of chi-square. If you go back and check, this value has consistently been 3.84. All right, that is our lower bound. We can do the same thing to get our upper bound. These are the same equations that we found in chapter 6, starting at a value of f equals 1, and we continue until f gets very, very close to 0. And after 4 iterations, we settle on a value of 5.5188. And we can still get those same values. Notice this chi-square, it's still 3.84. And that is because of how we set up our confidence interval. So in this case, our interval, our 95% confidence interval for the odds ratio based on our data from table 7.1 is between 0.93 and 5.51. This interval was narrower than our previous intervals from the cross-sectional study, showing us that this interval is really superior to the previous interval, because you want your confidence intervals to be very precise. And since they have the same level of confidence, but this is a narrower interval, we would say that this interval is superior. I hope that you really enjoy reading section 7.1 and that you learned something from this video. I'll see you next time.